Hi everyone, I'm excited to show you guys how you can use EyePop and Replit to create a computer vision powered app. So for today's workshop, we're going to have a quick overview of what AI models are, and we're going to specifically focus on computer vision models. After that, we're going to talk about EyePop.ai and how we are approaching the computer vision space and changing the way people work with computer vision models. Next, we're going to do a quick demo of a Replit app we built, which uses iPop's computer vision model I trained to engage customers of a certain brand, and also talk about different ways brands are using computer vision in high impact ways. After that demo, I'm going to show you how I built that demo step by step, first starting with building the computer vision portion in iPop, and then finishing with the front end portion in Replit. Any questions? Great. So what is an AI model? An AI model is a program that has been trained on a set of data to recognize certain patterns or make certain decisions without further human intervention. There are tons of different types of AI models, but we're going to be focusing on computer vision models. And computer vision models are models which are trained to see and understand images or videos. There are tons of different types of computer vision models, but we're going to be focusing on four. The first one here is object detection. So object detection models will tell you if a certain object you are trying to find is present in an image, and it's also going to pinpoint where that object is by drawing these bounding boxes on that object. So for here, we have a object detection model, which is trained on finding cows from an aerial view. And we can see all these boxes and it's finding all of them perfectly. There are also classification models, and these models will tell you if a specific object or feature is or is not an image. So there is no bounding box here, but we will be classifying if a certain object or feature is in an image. So here we have a classification model which is trained on different types of tumors, and it is classifying this medical image as containing a pituitary tumor. Next, we have key point detection models. These models identify important points on bodies or objects, like joints or corners, and you can use these models to do tons of things from sports tracking to gesture control. And finally, we have segmentation models. These models label every pixel in the image with a precise outline of the object instead of drawing those bounding boxes. So this is really useful for cases of self-driving cars, medical imaging as well. And there are a bunch of more models other than these four models in the computer vision space, but these are just ones I wanted to highlight. Now going into what it actually takes to create a computer vision model traditionally. You would need to first select the right model, and then you would need to pre-process your data and then normalize it. And then you can begin to actually run inference and start to run your model. And then once you run it, you would need to do a whole post-processing, making sense of the output of your model. And then you would need to continually deploy and maintain your model. So there's a ton of work, and not only is it take a high level of expertise, like a dedicated machine learning engineering team to do this, but you also would need a ton of time. It takes a ton of time to create these models, and that's where EyePop comes in. So we are a no-code platform that makes it easy to build these computer vision models without needing to code or hire an ML team. So our flow sort of looks like this, where you'll come in with your unstructured business data. So that's images, video, or live stream, and you'll upload that to our SDK or to our web app. And you'll create and train your model, and you'll be outputted this pop. And this pop or endpoint basically will be a combination of different models if you so choose, and it will output you this rich JSON data, which you can hand off to your developers, and they will use to power your product for any business outcome which you are looking for. Do you have any questions at this point? Great. So our models are low latency and are combinations of different models working together to provide the developers with the most with the most amount of data possible. So for here, for example, we have a person model, which is a combination of all of these models, and it's giving all of this data just under that one model. And you can configure these on the fly without having to change or restart any inference or servers, which is really awesome. So now we have now I'm going to show you guys a bunch of models we've already have on our platform that you can use right now just by signing up and creating a free account. This is completely accessible. So we have models to detect people, people with 2D points, people with 3D face, body, and hands, people plus common objects, people plus animals, people plus devices, people and sports equipment, people plus vehicles from a street level, text detection and OCR, vehicles from a traffic camera angle, sports player tracking, person with demographics. And you can also create your own model and then combine it with any other model we have in our pipeline. So for example, here we have a model where we trained it custom on detecting eyeglasses, and then we connected this to the person 2D model. So not only are we getting this data back about the eyeglasses, but also now with the person 2D model. Do we have any questions at this point? Awesome. So now transitioning to how brands are currently using computer vision in high impact ways. So we've seen some interactive experiences be built from the Star Wars brand. They created this May the 4th filter to advertise the upcoming Star Wars Day. And they're using computer vision to track faces and overlay this Darth Vader helmet. This creates a immersive experience for fans to engage with the brand. During the Tokyo Olympics, Nike used computer vision to detect when and where their logos were appearing on athletes, giving them real-time data on their brand presence across media platforms. So a few years ago, Coca-Cola launched a Share a Coke campaign where there would be names on water bottles and people would be posting this on social media. And to track their ROI from this campaign, Coca-Cola created a computer vision model to see how many people are posting it and tracking every image where their Coke bottles were used across social media platforms like Twitter, Facebook, etc., giving them real-time measurements on their ROI from the Share a Coke campaign, which is pretty awesome. So other than those use cases, there are some really amazing opportunities for creating loyalty apps or proof of purchase campaigns for your brand. So for here, we created a demo of Liquid Death, a sparkling water company, using EyePop.ai to train a model to detect liquid death cans. And whenever a user uploads an image of a liquid death can, we give that user 10 points and they can accumulate these points to unlock rewards. So pretty simple loyalty app, but using computer vision specifically on your brand and your product. So let me switch over to Replit and show you this demo live. Great. Awesome. So here we can see this is our front end, and this is all liquid death themed. So if we were to upload a can, we are going to be returned a image where our EyePop model is rendering those bounding boxes where it finds the liquid death cans. And the Replit app is understanding that EyePop detected these two cans and is thus rewarding us with 20 points. And we can see that with these 20 points, we can get these different rewards. So now that we've uploaded 30 cans, we can get some limited edition merch. Awesome. But if we were to upload a can, which looks like Liquid Death, but actually isn't, then we wouldn't get any points. So this is how you can train a vision model specifically on your product. All right, so there's no points awarded here. Awesome. Do we have any questions here? Awesome. So now we're going to jump over to EyePop, and I'm going to walk you guys through actually creating the computer vision model to detect liquid death cans. And from then, we're going to connect it to Replit. If you don't have an EyePop account, feel free to hop onto our website and make one. It's completely free, and you should be able to be up and running in less than 2 minutes. So once you actually land onto our dashboard, you'll get to a point which looks like this. And you can create an AI model from here or create an endpoint. And our endpoints are essentially ways for you to combine those different models together. So we're going to be creating a AI model, and we can decide if we want to find different objects or auto tag images. For this demo, we're going to be creating a object detection model. And now from here, we can just name our model. So liquid death. And now we want to place a label. So these labels are what we are trying to find in our image. And it needs to be, plain and simple, just descriptive of what we're trying to find in our image. Great. Now we just need to upload our images to the model so it can train on it. So I have some um, I have some images already here organized in a folder. So I have an image called Liquid Death Cans and a folder called Negatives. And if I just go ahead and upload these in here. Now, our auto labeler is going to go in and begin to prioritize these different images based off what's the most unique and what it thinks would help the model trained the best. And then it's going to begin to draw those boxes, which we saw on the images itself, expediting that process of manually having to go through the images and draw those boxes. So let me skip over to this page where we are already having a preview. So you'll be on a page like this, and you'll see all of your images uploaded. And once you click continue, it's going to begin to start that auto labeling process. And that takes a few minutes, so let's just skip ahead to once it has already auto-labeled. Awesome. So we can see these boxes are placed on our images. So these boxes with the solid lines are images we've already gone through and trained them on. But if we were to click reset, we can see that these are now dashed. So our job is to go through all of the images and just approve them if the box is around the object we're trying to detect. So in this case it is, in this case it is as well. But if we were on a object like this and we click reset, we can see the auto labeler is pretty good. But as we decrease our threshold, we can see that it is having these guesses. If we were to go to this image, you can see it has a ton of guesses, but as we narrow it down, there are less boxes. So once you go through your image set and you are done labeling, um, oops, you'll get to the end of your data set and you will land on a page where it looks like this. You'll get a summary of all the images you've uploaded, the images you've approved, and how many of those images are negative examples. So negative examples are images where the object you're trying to detect is not present, but it looks similar enough that your computer vision model might think that that could be it. So you want to really train your model to understand what is exactly you're looking for, which are these bottles, and what looks similar to these bottles but isn't actually the liquid death cans. Great. And once it begins to train, you'll land on a page um, which looks like this, and you can see it is currently training. And if we were to click onto here, we can see that the training is in process, and we can see that this is our current line, and this is telling us how well it's training. Um, this is the confidence curve, and it is checking how precise the model is and how well it found everything we wanted it to find. So you can deploy these models once it's done training. Um, for example, so you can deploy these on the cloud and you can combine these with other models instantly just by clicking a box. But if you actually wanted to deploy this to the edge as well, you can deploy it to any to Qualcomm, Snapdragon, and other edge devices we have. But by creating this pop, we are now combining this model with this person in 2D body points model. And once we create it, we'll be able to play around with this model. Once this is done loading, it's going to appear in here, and our model will be present here. And from here, we can integrate this trained model into our Replit app, into our project. We can also integrate it through plugins. We have a Python SDK, and if you want to test out the app on the model on a Jupyter notebook, you can click Open Notebooks. But for this demo, we're going to be using it in the sandbox. So once you click Open Sandbox, you'll be in a Replit template we've created, and all you need to do is click Remix Template. And I've already created a few apps, so I'm getting paywalled. However, it should look like this. And then once you click Use Template, you will be on a page which looks like this. And now from here, it is telling us that all we need to do is upload our API key and our pop ID, and then we have connected our computer vision model to Replit itself. So if we go to all tools here and we click secrets, we'll see that the EyePop API key needs to be inputted here and the pop ID needs to be inputted here. So if we return to our dashboard, we can grab the UUID and input it into the pop ID. And we can also grab our API key and input it in there. And once we've done that, we've successfully connected our computer vision model to Replit. Now, the next steps to create your app would be to actually um, give Replit a prompt and to begin going from there. So I like to put together a document where I'm outlining exactly what I want to build on a high level, going through the product's summary to core features to the way the user flow should look, um, talking about how the visual design needs to look, and basically giving the agent everything it needs to know about what I'm trying to build and how it should look and what it needs to do. So once we put this together, we can just copy this and paste that into here. That's what I pasted right there. And I told it, look at our attachment and create this app. If you have any questions, please let me know and I'll clarify. And once we send that in, it is off to the races. Replit agent is going to go through, look at the requirements, update everything accordingly. And sometimes you can, one shot this project. One shot meaning that it only takes you one prompt to get your desired outcome. To do that, you need a really thorough prompt that walks through everything clearly and maybe provide it some documentation, etc. But in this case, it took me a few back and forths to get our app up and running. So we had this issue where it wasn't grabbing the most updated version of the EyePop AI SDK. So then we needed to do it. It was still having the same issue. I knew what it needed to do. It needed to grab the latest version from the doc. So we just told it to do that. And once it did that, we were outputted this preview, which looks really good for like 1, 2, 3 prompts. The demo I created was here, and this took me, yeah, a few prompts. But yeah, that's how you connect your computer vision model from EyePop into Replit and how to use Replit to create whatever project that you're working on or whatever product you're working on. Great. Do we have any questions? Great. Well, thank you guys so much for coming. This was a great workshop, and I hope you guys have a better understanding of how to use EyePop to create the computer vision model and how you can easily integrate that into your Replit app. Awesome. Thanks, guys.